So anytime we're trying to divide things, we can do long division, we can do synthetic division. My advice is always to do synthetic division. So if you're given a problem such as this, divided by 5x plus 12, or by 2, excuse me, 5x plus 2, we're going to do synthetic division where we use the box and we drop that first term. Now the number that goes in the box is whatever makes this equal to 0. When there was no coefficient, we just change the sign and put the number in. If it's something like x minus 3, we just put a 3 in here. Here, if you're not sure, set it equal to 0. So negative 2/5 goes in the box. Negative 2/5 times 5 is negative 2. Negative 8 and negative 2 is negative 10. Negative 2/5 times a negative 10 is 4. So the remainder is 16. And that's your answer. Okay, you can get your remainder by the last thing in synthetic division. Possible roots, if you recall, it's the factors of the constant over the factors of the leading coefficient. They're just asking for the possible ones. They're not asking for the actual answers here. So in this case, it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. That's every single factor of 12 over 1. Now I put every factor over 2. Plus or minus 1/2. You don't need to put repeats. 2 over 2 is 1. I don't need to repeat it. 3 over 2. 4 over 2 is 2. 6 over 2 is 8. Oh, I'm sorry, 6 over 2 is 3. 12 over 2 is 6. We don't need to put the repeats. Now I go over 4. Plus or minus 1/4. 2/4, 1/2. We don't need to repeat it. 3/4. 4 over 4 is 1. 6 over 4 is 3/2. We already have it. 12 over 4 is 3. Already have it. Plus or minus 1/8. 2/8 is 1/4. Already have it. 3/8. 4/8 is 1/2. Already have it. 6/8 is 3/4. Already have it. 12/8 is 3/2. We already have that one as well. Okay. Any questions with that? That's your answer. Those are your possible solutions. All right. So let's go through the roots again here. So my roots, my leading, or my coefficient, or I'm sorry, my constant is 1 and 24. So I got to list all the factors of 24. And then it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. Okay. And now you do need to try that. So 1, 1, 5, negative 10, negative 20, and 24. Drop the 1, we get 1. That's 6. We get negative 4. Negative 4 and negative 24. And negative 24 is 0. So that means 1 is one of our factors. If 1 works, you do have to try it again. 1, 6, negative 4, and negative 24. Drop the 1, we have 7. Now we have 3. That doesn't work. So 1 doesn't work a second time, just the first time. Okay? Okay, now, try 2. 1, 6, negative 4, negative 24. We drop the 1. We get 8. 8 times 2 is 16. We get 12. 12 times 2 is 24. We get 0. And now we're left with 8x squared plus 8x plus 12. So 2 is an option. 1 is an option. When I factor what's left, I get x plus 6, x plus 2. I still have to track or count for the other 2. If 1 and 2 are factors, that means it's x minus 1, x minus 2. So my zeros or my potential roots are negative 6, negative 2, 1, and 2. And And that's my answer. C of x, d of x, we're subtracting. They want d of x minus c of x. It's simply this. 3x squared minus 4y plus 8 is my d of x. And I'm subtracting my c of x, which is 4x squared plus 7y minus 9. We're distributing the negative. 3x squared minus 4y plus 8 minus 4x squared minus 7y plus 9. That negative goes to both terms, and then I'm combining my like terms. 3 minus 4, negative 1. Negative 4 minus 7, negative 11. 8 and 9 is 17. There's your answer. For something like this, I would do f of negative 2 first. F of negative 2 equals negative 2 squared plus 4 times negative 2 minus 7. Negative 2 squared is a positive 4. 4 times negative 2 is minus 8, minus 7. It's negative 11. So my f of negative 2 is negative 11. So now I'm going to do g of negative 11. I can substitute negative 11 in for f of negative 2. And that's simply 2 plus a negative 11. My answer is negative 9. There's my answer. (64) n to the 9th to the 5/3. That 5/3 goes to everything. So I'm going to do the cube root of 64 n to the 9th raised to the 5th power. Make sure I'll put the 5th power outside the radical. My advice is always to apply the index first. The cube root of 64 is 4. 9 divided by 3 is 3. So this is 4n cubed to the 5th power. Okay. 4 to the 5th power, I believe, is 1024, but I will check it in my calculator here. So when we do 4 raised to the 5th power, you get 1024. N cubed to the 5th power is n to the 15th. Once again, that fractional exponent, the denominator is the index, the numerator is the exponent. Here, simplifying, you got to get the same number underneath both radicals. So I'm going to simplify 24, and I'm going to simplify 54. 2 and 12, 2 and 6, 2 and 3. So this simplifies to 4 times 2 root 6. For the 54, 2 and 27, 3 and 9, 3 and 3. Pair of 3's, and I have a 2 and 3 left over. So this simplifies to, instead of root 54, 3 root 6. Okay. 4 times 2 is 8. 8 root 6 minus 7 times 3 is 21 root 6. And 8 minus 21 is negative 13 root 6. Rationalizing denominators, I've got to get a perfect cube under the denominator. You might have seen this as a perfect square. When you have a cube root, you need to get to a perfect cube. So I'm going to multiply the top and the bottom here by the cube root of 25. And the reason why we do the cube root of 25 and not 5 is 5 times 25, that's the cube root of 125. On the top, you have 4 times the cube root of 25. We can take the cube root of 125, that's 5. Okay. The key on these problems is you have to be left with no radical. Oops, not 3, I'm sorry, 5. You have to be left with no radical in the denominator. So it's not just, if this was a perfect square, it'd be square root of 5 on top and bottom. Since it's a cube root, you need to get to a perfect cube. So 5 times 25 is 125. 125 is a perfect cube. Down here, this is probably one of the simpler ones. 19 divided by 4. and taking the fourth root of 32. I'll start with the 32. 2 and 16, 2 and 8, 2 and 4, 2 and 2. The 4 2's means the 2 goes on the outside, and we had 1 2 left over, that goes on the inside. With a variable, it's the exponent divided by the index. 19 divided by 4 is 4 remainder 3. The quotient's the exponent on the outside, the remainder's the exponent on the inside. And finally, rationalizing this one, we have to change the sign. You're using what we call the conjugate. You're foiling on the bottom, which will eliminate that middle term. You're distributing on the top. So the top here becomes 5 minus 5 root 3. The bottom becomes 1 times 1 is 1, minus root 3, plus root 3, and then root 3 times a negative root 3 is minus 3. The middle terms cancel, and we're left with 5 minus 5 root 3 over a negative 2 on the bottom. You can leave it like that, or you can put the negative on top and write it as negative 5 plus 5 root 3 over a positive 2. It's usually not good form to leave a negative in the denominator, so you could see the answer written like that as well. Either answer is correct, though. All right, here with i's, or with imaginary or complex numbers, we're just foiling. 4 times 7 is 28, minus 20i, plus 21i, and then it's negative 15i squared. We need to know that I squared is the same thing as negative 1. Okay? So this becomes a positive 15. 15 and 28 is 43. Negative 20 and 21 is plus I. This one here is an interesting one because you have the sum of two cubes. Okay. We can simplify the bottom and see what cancels. There's not really much to factor up top. But if I simplify a cubed plus 64, or x cubed plus 64, that goes back to this formula here, which is a plus b, a squared minus ab plus b squared. So my bottom here, I'm going to have x squared minus 4x plus 16. But on the bottom, this becomes my a is x and my b is 4. This becomes x plus 4 times x squared minus 4x, the 4 squared plus 16. The top cancels, and you're left with 1 over x plus 4. All right, you will have to know how to factor in sum and difference of two cubes.